Hello and good afternoon. CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be a continuation on the challenge activities. We're now looking at challenge activity number 4, which revolves around configuring EIGRP, but this time we're going to be using the 64-bit mode, or the EIGRP named mode. So if we take a look at our scenario here, this is a topology that we've seen before when we were using, I think it was delay, in order to manipulate traffic patterns coming across these two WAN links here. So what do we have? Customer gained some experience with IPv6. We wanted to unify the configurations. So we're going to go ahead and configure default routes for IPv4 and IPv6. Links toward the distribution center must be utilized unequal load balancing, and so we're going to have to set that up. And what else do we have here? Make sure the branch routers don't receive any query messages, which means we're going to be setting those branch routers up as stubs. In the previous challenge, number 3, we could have also set the branch routers up as stubs as well. And then on branch 2, allow EIGRP adjacencies only on the uplink toward the HQ. And in fact, we're going to do that on all of the interfaces. So let's go ahead. We're going to start with HQ here, Ethernet 0102, serial 1011. Trying to remember that there. All right, so we're on the HQ router in user exec. Let's transition to to privilege exec, and then into global config. Let's say do show run section EIGRP. Let's see if we have any EIGRP left. And let me see something here. Is this 15.4? No, we're 15.2. Okay, so the command that I was going to look for was under the EIGRP, existing EIGRP config. If it was there, you can type in EIGRP space upgrade -CLI, and that will auto-magically convert your legacy classic /32-bit mode EIGRP configuration to the 64-bit mode configuration. All right, so let's go ahead and dive in here. So we're going to say router EIGRP CCIE, because that is where you guys are headed once you get done crushing your CCNP. And then do show IP interface brief. Let me see, do show IPv6 interface brief. Okay, so we've got v6 and v4 information here. And I'm going to kick this off here. Let's go address family IPv4 unicast. Autonomous system, we'll use 99. The router ID, so we've got IPv4 addresses, so we don't need to set manually unless we wanted to set it to a value that we prefer. We wouldn't have to set it because we have IPv4 addresses that can be taken and used as the EIGRP router ID. All right, so we're looking at the different interfaces we have here on the HQ router. And so we're going to run it on Ethernet 0102, serial 10, and serial 11. So those all fall within a specific range. But here's what I'm going to do. We're going to make this a little more precise. Do show run, and let me get 224. So 252, 250. So these are all a bunch of /30s here. So I could put a single statement, but I think what I'm going to do is let's go ahead and say network 192.168.255.1, and we are going to match that exactly. And so we should end up with an adjacency starting up here on the, and once we get over there to the other side. So then we'll say 255.5. So we're going to make it specific to the interface, the exact IP address on the interface, 255.9 and then 255.13. All right, so we've got EIGRP set up there. The next thing we need to do, let's exit back out, address family IPv6 unicast, autonomous system 99. And remember, there is no network command. What happens? Does anybody remember what happens? If I were to say passive interface, or actually we need to get under AF interface default. So, and actually before I do that, so just to recap here, if I say do show IPv6 EIGRP interfaces, when you run that command, it actually starts EIGRP for IPv6, or I should say EIGRP for IPv6, it will actually activate every single IPv6 interface. So any interface with an IPv6 address that is up is now running EIGRP. Now, that may or may not be what you're after, and so this is what we were headed toward here. So we're going to say AF interface default, and I'm going to say, we're going to say passive interface on all the interfaces. And then we're also going to say shut down, right? So we're going to shut down and passive every interface. So what I need to do is AF interface Ethernet, and I don't believe, what's the one that's going out? Ethernet 00. Yeah, so we're going to leave that the way it is. So I'm going to say Ethernet 01, and we're going to say no passive interface and no shutdown. And then AF interface Ethernet 02, no passive interface, no shutdown. And then we're going to say the serial 10 and 11, so interface serial 10. Oh, I just took myself out, unfortunately. Forgot the AF interface. So the bonus lab, router, EIGRP, CCIE, address family, IPv6 unicast, AS99, AF, interface, serial 10, no passive interface, no shutdown, and then AF interface, serial 11, no shutdown, no passive. All right, so let's take a look at our configuration section here, and we'll go ahead and say do show run section EIGRP. And you can see the IPv6 section, which starts with the stanza right there, is a pretty robust section, right? Because we went ahead and we did the passive interface default. So I didn't do it for IPv4, but that's okay. We did it for IPv6. So the configuration here, at least from the HQ perspective, looks good. So let's go ahead and configure out everything else here. So we're going to go out to branch 1. We'll get basic connectivity set up. So on branch 1, we'll say show run section EIGRP. Let's see, do we have any EIGRP set up? We do, and we are going to get the bonus lab on this. As you can see, the autonomous systems were set up as 10 and 20. So we'll make this happen pretty fast here. So we're going to say no router EIGRP CCIE. And then we're going to say router EIGRP CCIE, address family IPv4, unicast, AS10. And we're going to add, and let's just throw that one massive network statement in there, 192.168.255, was it? Yeah, 255.00.0.0.255, and that should actually pull everything on. So apparently trying to be too clever by half there. All right, so we've got all our adjacencies set up here. So now I'm going to back out one address family IPv6 unicast, AS20, and that is going to fire up the interfaces auto-magically, right? So you see there is no network command, and we don't need to go under the interface in order to enable it. Okay, so let's take a look here. Do show run section, or actually include route. So I'm looking to see what we've got set up. So as you can see, we already have our static routes, because remember, again, we're going to go ahead and redistribute these to all of the branches in the distribution center in order for them to have a default route out of their network. So I'm in the IPv6 address family, but this is not where we do the redistribute command, right? You can see there is no redistribute command here. So what I'd have to do is go to topology base, something that's going to affect the entire IPv6 topology, and then I'm going to go ahead and say redistribute static. Now, I could put a route map. I could even change, we'll change the metric here. We'll just change it to 55, right? Whoops. Oh, no, okay, I see. So we'll just leave it the way it is. So we'll just say redistribute static. And this is enough to redistribute the static IPv6 default route. If we were to say address family IPv4 unicast AS10, then we would go into topology base again and simply say redistribute static. So let's come over to branch 1 and say show IP route, and you can see there is the DEX that we have right there. So we have picked it up. What about for IPv6? Show IPv6 route, EIGRP, and absolutely, as you can see here, we've got the default static route, And we've got IPv6 configured and set up, and everything looks good. All right, so now what we're going to do is let's check. We had everything set up here on HQ. Let's check branch 2 and the distribution branch. All right, so we needed to, on the distribution branch, they wanted us to, let me double check that. I believe it was on the distribution branch. We needed to, okay, make sure the branch routers do not receive query messages from the HQ when a route is lost. So hold on one second. So we've got the default routes. We've taken care of that. Okay, both links toward the distribution center must be utilized using unequal cost load balancing. We'll save that for later because this is low-hanging fruit here. And so this is on the branches. So on branch 1, we'll get in the global config. We're going to say, what is the name of the EIGRP process here? Do show run section EIGRP. And it's just Cisco. So we're going to say router EIGRP Cisco. And we're going to make this a stub router. Now remember, when I change this and I get into address family IPv4, unicast, autonomous system 10, and I say EIGRP stub, the hello packets are now going to have different values. And one value that's specifically important here is going to be the value that tells the hub router, do not send me query packets because I will not know how to get to any network that you've lost because there is no alternative path behind me. So in other words, when we look at our diagram here, what we're saying is that when we turn branch 1 into a stub, and we could have done this in challenge activity 3, branch 1's hellos will show up here saying, hey, I am a stub. And that means HQ, you can see I don't have any other paths over here that loop me back around somehow into the environment. So do not send me any query messages because I'm not going to know how to get to the network you're going to be asking me about anyway. So don't bother me. I don't want to hear about it. And so that's the importance of the stub. It's also the major importance of summarization. It's all about limiting the size and the scope of the query domain, because that's the most important thing with EIGRP, is limiting the size of that query domain, especially when we're talking about long distance, low speed links. We need to make sure that we are limiting the size of the query domain. So back over here on branch 1, we're simply going to say EIGRP stub. And so by default, what are we going to advertise out? Well, we're going to advertise connected and summary. So if I were to come to HQ and say, do show IP EIGRP neighbors detail, right, let's take a look. Here is the peering with branch 1, and you can see stub peer advertising connected and summary. And so that's it. Right now, we did it under address family IPv4 unicast. So we need to do the same thing, because what was the command I ran here? It was do show IP EIGRP neighbor detail. If I say do show IPv6 EIGRP neighbor detail, we take a look at that same peering, and well, you can see here that none of the peerings are set up as stubs. So we need to go under the address family IPv6 unicast AS20, and we need to say EIGRP stub. And this is going to go ahead, it's going to reset that EIGRP neighbor adjacency. It'll go down and then come back up, but now back on the HQ router, what are we going to expect to see here? Exactly. Here is that peering, and again, stub peer now for IPv6 information. All right, and so that covers us on the branch router, or branch 1. Let's come to branch 2, and we're going to go ahead and do the same thing. Do show run section EIGRP. So you can see the config is already there. So we're going to say router EIGRP Cisco, address family IPv4 unicast AS10, and then EIGRP stub, address family IPv6 unicast AS20, and then we are going to say EIGRP stub. All right, now you can see that you have to do it for both address families. If I didn't do it for the IPv6 address family, and an IPv6 route behind the HQ went away, he would end up sending a query to branch 1. Or I said to either of the branches if we didn't do it under the address family IPv6 unicast. So now we've got that taken care of. Let's pull this back up here on branch 2. Allow EIGRP neighbor adjacencies only on the uplink. Okay, so we did not take care of that. So let's go ahead and say, and I guess they're looking for us to do show, let's see here. Get the cursor back. There we go. So do show run and section EIGRP. And this is pretty straightforward, and so do show IP interface brief. I think we've got a single interface out. Yeah, Ethernet 00. So here's what we're going to do. We're going to say AF interface default, passive interface, and shut down. And then I'm going to go AF interface Ethernet 00, no shut, no passive. And then we're going to go into interface loopback 0 and say no shut. Interface loopback 1 and say no shut. Oh my goodness, I did that again. I forgot to put in AF interface and it took me out. So here we go. Bonus lab. Router EIGRP CCIE, address family IPv6 unicast, which is where we were, AF20, AF interface, and we got the first loopback right, loopback 1, AF interface. Oh, sorry, we got to get into the address family IPv6, unicast AS20. Do show run did section EIGRP. I missed something up here. Let me see what we've got. Yeah, address family IPv6 unicast. There's the IPv4 and the IPv6. Do the loopbacks do show IPv6 interface brief, and loopbacks do have that. So let me exit out here. Let's go ahead and say router EIGRP Cisco. Address family IPv6 unicast autonomous system 20. Okay, I must have been typing something wrong earlier. AF interface loopback 1. All right, so we'll say no shut. AF interface loopback 2, no shut. And then address family IPv4 unicast autonomous system 10. We're going to say AF interface default, and then we're going to go ahead and say shut down and passive all the interfaces, right? So everything is shut down or passive. So now I need to get into AF interface Ethernet 00 and say, and again, it's each of the interfaces, right? As we do this into the different address families, when I do the AF interface Ethernet 00 and I say no shutdown and I say no passive, we're going to get the adjacency back. And if I hadn't done EIGRP for IPv6, we'd have to go do that, right? Because these are mutually exclusive configuration sections. One for the IPv4 address family, one for the IPv6 address family. So keep that in mind, that you need to do that for both address families. So let's say AF interface loopback 0 and say no shutdown. Let's see if we can remember to type in AF interface loopback 1, no shut, and then AF interface loopback 2, no shut. And so now if I were to say do show IP EIGRP interfaces, you can see the only interface running EIGRP is Ethernet 00. If I were to say do show IP protocols, when we look at EIGRP, you can see that it is advertising loopbacks 0, 1, 2. It's just that they are not sending hellos, and that's what we want. And so to do the same thing for IPv6, do show IPv6. What did we say initially? EIGRP interfaces. And there we go. And then we say do show IPv6 protocols, do show IPv6 protocols. And loopback, and we need to take care of loopback 0, it looks like. So let's say address family IPv6 unicast AS20 AF interface loopback 0. How about no shut? And it should be passive. So let's rerun that do show IPv6 protocols, and there we go. So now we've got loopback 0 in there as well. All right, so that kind of takes care of the basic configuration. And so now what we want to do, if I remember this correctly, we want to go back. Let me take a look here. I apologize. Keep forgetting. All right. Configure the default routes. Unequal cost load balancing. And the distribution router need to be summarized. So we'll take care of the summarization. I'm saving the variance command and that calculation for last. So we are on the distribution router and user exec. Let's get into privilege exec and then into global config here. And let's say do show IP interface brief, and the loopbacks need to be summarized. So we're dealing with 172.16s, and then let's say do show IPv6 interface brief, and we've got 90, 91, and 92. All right, I think we've got enough space to work this out right now so that we can summarize both of these entries here. All right, so let's come up here to the pen. So we'll take care of these guys first. The IPv4 obviously is going to be the easier, or I should say the lower hanging fruit for us. So we know that these 8 bits and those 8 bits match. So we have 16 bits that already match for all 3 addresses. There is the interesting octet, not the hextet, the interesting octet. So we've got 96. Well, what does that look like in binary? So we've got 128, 64, and 32. So right there, that's 96. So I already know that the next 5 bits that I'm laying out, those are all going to be zeros. And so there's 96, and that's my decimal value. So then 98 is pretty easy to figure out from here. We only need to add 2, so we know that there's my 2, and then everybody else is a 0. And then 100. Again, there's 96. Well, I only need 4 for that. There's the 4-bit position, and then everybody else is 0. All right, so there we go. And it is right there that they no longer match. And the quick trick here, remember, if I say 2 to the number of bits to the right of the matching bits, that's going to tell me how many networks I am actually representing in my summary, right? So we've got 16 bits. There's 17, 18, 19, 20, 21 bits that match. So we know that our prefix, or I shouldn't say prefix, we know our subnet mask is going to be a /21. Now the only question is, what is the network number? So it's going to be 192.168, and then that third octet, there's the matching bits. What are our bit position values? 64 and 32, 96.0/21. So there's my IPv4. Now let's come down and take a look at the summaries for the IPv6. So again, we've got the first hextet. All 16 bits are going to match there, there, and there. And then remember, the leading zeros have been dropped here. So what we're really dealing with in hex is 0090, 0091, 0092. And remember, this is our hex. So we need to take that hexadecimal and we need to convert that into binary. But we're going to do it at that boundary right there. So it's within the hextet where we find and actually, sorry about that. I shouldn't have even drew it there. I should have drew it right there. I was thinking decimal values. I was like, oh, 90, 91, 92. So yeah, this is where it's wrong. But remember, each of these is an individual hexadecimal character. So we match right here. 9 matches all the way down. So I've got 4 bits and 4 bits. So I have an additional 12 bits that match. Remember, each hexadecimal character is 4 binary digits. So it's right there, that last hexadecimal character through the IPs, that do not match. And so in binary, rather simple, 0 is going to be all zeros in binary, and in decimal that equals 0. The 1 in hexadecimal, 0001, and that is 1 in binary. And 2 is 0010, which is 2. So again, very easy. no alphabetical characters A through F to deal with here, so it makes it very simple to look at. So that is where the binary digits no longer match. So we've got 16, 16, and 16. So 16 plus 16 plus 16, and that's how many bits. We've got 48 bits there that match, plus the 12 we found here, and then 13, 14. That's going to give me a prefix length of /62. So now the only question that needs to be answered is, what is the prefix? Well, it's going to be 2001 colon db8 colon 0 colon, and now we get to that interesting hextet that we had to tear apart here to come up with the values that did not match. Well, we know that the 9 matched, so we could put the leading zeros, but I'm going to drop them. I'll just put dash dash for those leading zeros. And again, I'm just putting that there as a placeholder so that you can see I'm accounting for those 2 zeros. They would be dropped, and you would not put dash dash. You would just simply put the colon 9. I'm just putting them here as placeholders for us. And now we get to that last hexadecimal position. Well, where did they stop matching, and what, if any, bit positions were on? None. So we've got 2001 db8 0 90 colon colon, and remember, you don't put dash dash. I was just showing you placeholders for the 2 zeros here in our equation. All right, so those are the summaries. And 192, 168, 96, 0, 21. I'm trying to remember these. All right, so let's dive in here. Whoops, I'm going to make sure we get rid of the pen there. All right, so on the distribution router, we're going to need to step into the address families again. So let's get in here. Let's get into, we're in global config. So we're going to say router EIGRP Cisco, address family IPv4 unicast AS10, and then AF interface. So what interfaces are we using here? Serial 00 and 01. Good, nice and easy. All right, so interface serial 00, and this is where we're going to say summary address 192.168 dot 192.168 dot, and then I'm looking at 96 was what we were. Yeah, 96 dot 0, and then we've got a /21, and I think we can get away. All right, fantastic. So we've got a graceful resync there with the neighbor. But the important thing is the summary has been pushed out, the serial 01 interface. If I were to say AF interface serial, or I'm sorry, the 00, AF interface serial 01, we do the exact same command. Because again, we want to make sure that the summary is being advertised out both of these serial links. Because if I only go this way with the summarization, all of the more specific routing information would go this way. And then this would probably be where the majority of the traffic would come because of the longer, more specific matches. Because again, the summary is going out this way. This would have all of the more specific information, and that could result in some issues. In fact, when we do the IPv6, we'll take a look at that. So let's go ahead now on the HQ router here. All right, there we go. Let's go back to the distribution router here, and we'll finish up for IPv6. So address family IPv6 unicast AS20 AF interface serial 00. And now that I think about it, I probably should have done this at the same time. So summary address, and we were 2001 colon db8 colon 0 colon 90. Yeah, colon 90 colon /62. All right, so we do the IPv6 summary. So now I'm doing it out serial 00. If I come over to HQ, let's take a look here. We'll go from user exec to privilege exec and say show IPv6 route EIGRP. So take a look at the different, sorry, I want to stay on HQ there. Take a look at the different information that we're picking up via the serial interfaces. And so it would be all this information below this line here. So you can see on the serial 11 interface, where we haven't done the IPv6 summarization yet, I have all of the /64s. And hopefully you see that. So I've got all the /64s, which are longer matches than the /62. So in effect, for all longer, more specific matches, all traffic right now is going to go over serial 1.1. And again, let me repeat that to make sure I'm clear. I'm not saying that all traffic is going to go over serial 1.1. What I'm saying is all traffic where those longer specific /64 prefixes are in use will go over serial 1.1, right? No traffic for these more specific interfaces is going to go over serial 1.0 because the more specific, longer matches are here because we haven't summarized. And so let's confirm that actually. Let me clear the screen here to prove that that's what's going to happen. And let's see, what are we dealing with here? 2001 DB8. So 91, and let me get a more specific, let me get the IP here. I think it might be : do show IPv6 interface brief : 1. Yeah, so 2001 DB8 0. So we're going to go to 92 : 1, and I'm going to do it from branch 1. So from branch 1 here, if I get in privileged exec mode and I say trace to 2001 : DB8 : 0 : 92 : 1. And what we should see here is it'll obviously go to the HQ router. So while it's thinking there, what we're going to see is branch 1, it obviously comes here. It has to come to HQ, but it is then going to choose that serial 1.1 link. It will not choose serial 1.0 because the longer /64 match is over on serial 1. And so you can actually, I mean, obviously we're going to be doing some different things here, but probably not recommended, but that would be a way to do some traffic engineering if you wanted to pull the more specific matches here, do the summary here on the 1.5 meg connection, and then leave the more specific information advertised out serial 00. So let's clear this here and let's come over to branch 1 where hopefully, and the trace is taking, oh, there we go, okay. So we went to 100 : 1 and then 103 : 2. So let's take a look here. Show IPv6 interface brief. So the 100 : 1 is Ethernet 02, and then we jumped out serial 1.1, 103.1. What if I go from branch 2? Let's get into privilege exec and we'll say trace 2001 DB8 : 0 : 92 : 1. And let's see what happens. So we'll give this a second here. All right, come on, traceroute. IOU is just a little slow. All right, so there's the 101.1 that gets me over to the HQ router, and then the 103.2, which again, if we look at branch 1's results, were the same, which means we are all going over serial 1.1 because that is where the longest match is. And the reason that I'm kind of harping on this is a lot of learners become confused thinking, no, it's administrative distance. That's the tiebreaker. Well, it is if and only if the prefix length or for IPv6 or the subnet mask for IPv4 are the same. If those values aren't the same and there is a longer, more specific match, the longer, more specific match, irrespective of the administrative distance values, is going to be selected, right? So keep that in mind. Longest match is the #1 selection criteria. All right, so let's get back on message here. I'm in AF interface and I'm completely loss. Do show run section EIGRP. I think we need the summary under, yes, AF interface serial 11, AF interface 01, sorry about that, AF interface serial 01, and we're going to recall that same summary command so I don't have to remember it. And there we go. So now what we should have is there should be some kind of symmetry between the information that's being advertised out. So back on HQ, if we were to go ahead and say show IPv6 interface, sorry, show IP route EIGRP, you can see that now we pick up the 62 here on serial 10, because again the delay for 2 megabits a second is less than the delay on the other interface. So we've got a better metric coming over this interface as compared to the other. So if I were to say show IPv6 EIGRP topology, you can see we've got 2 paths to get to that summary right there that we created. But when we look at the metric, right, you can see then again the 64-bit numbers are just monstrous to deal with. When we look at the 64-bit metric here, especially over a T1, 1, 2, 3, 1, 2, is that billion? So we've got 1.63 billion compared to 1.735 billion. So that's why, again, as a review, this is the successor. In other words, the next hop router is the successor. And when it says via, that guy right there is the successor next hop router. Here is the successor route, that 2001 DB8, that summary that we created. We can see the feasible distance, but we know that that is not the feasible distance. That is the computed distance, because these values can and do sometimes change, while the feasible distance is going to stay exactly the same as from the moment it went from the active state into the passive state. Once it's in the passive state, that is the value, the metric, right? The feasible distance for the successor route. But this is the computed distance down here and can change. This is the reported distance. And so is this a feasible successor? Does it meet the feasibility condition? And just by looking, you can certainly tell that yes, it's going to. So remember, the feasibility condition states, right? So to meet the feasibility condition, the reported distance of the candidate feasible successor must be less than, and strictly less than, not less than or equal to, strictly less than the computed distance of the current successor. And here we can see that 163,000 is definitely less than 1.63 billion. So it meets the feasibility condition and therefore shows up when we say show IPv6 EIGRP topology. So we've got a feasible successor, which means if this path were to go away, the diffusing update algorithm is not going to have to fully reconverge. We have a standby feasible successor route that we can guarantee loop freedom with mathematically, knowing that we can install that immediately into the routing table and have it be used in the event that the successor goes down. Okay, so good review of the topology table there, and again, these 64-bit values are just crazy. All right, so let's go ahead, and this is probably a great time to finish things up here, because now what we're looking at is we've got, I believe, one task left. We took care of everything, and I'm trying to imagine what it is that's left. It's got to be the variance setup, and so that's what we're going to do. So variance command. There's two conditions that need to be met in order for the variance command to be able to be used. And I guess we'll put number 2 there. I'll put number 1 up here. The first condition is that you can only use feasible successors. So when you type in show IPv6 EIGRP topology and you don't see any feasible successors, we know the successor is always listed first. Feasible successors will be listed after the fact. But like for this prefix here, oh, well, actually that's connected, so we don't want to do that. Let's do this guy here. So we'll say this guy here. He only has a successor. He has no feasible successor. So for that prefix right there, let's say it went out to router 99. I couldn't do unequal cost load balancing because there are no feasible successors. There are no other next hop routers that meet the feasibility condition. So therefore, let's say that this, again, it's via, let's say it was via router 99. I can't do unequal cost load balancing. If I were to say show IPv6 EIGRP topology all dash links, all dash links, and let's say that for this successor route, I had 5 additional non-feasible successors, I can't use a single one of them because none of them meet the feasibility condition. So that's rule number 1, and that's the rule I always start with because that's the easiest one, the lowest hanging fruit in order to pick off how are we going to do this. But before you even ask that question, can we do it? Right? Do I have a feasible successor? So when we look at our summary advertisement here, that /62 that we created, summarizing those IPv6 prefixes, and we summarize the IPv4 ones just the same, but we're looking at the IPv6 information here. When I look at this information, I see the computed distance here and the computed distance here. So step number 2 is what is the variance multiplier that I need to use to ensure that that worst value right there, right? Or I'm sorry, let me go, I'm doing it backwards. That this best value right here, when multiplied by the multiplier, the product is greater than the computed distance of the feasible successor. So in other words, we're saying the current successor, I'm going to multiply this by some multiplier value in the variance command. It could be 2, 3, 4, but whatever I multiply that value by, it must be greater than the current greater than the current computed distance of the feasible successor. Because we're basically tricking EIGRP into thinking, oh yeah, the current successor, their reported distance is this number times some variance multiplier. And so we're kind of making EIGRP behave in a sort of lenient fashion and having it look past the fact that we can't do equal cost multipathing here because these are not equal metric values. So we're going to trick EIGRP with a variance multiplier, and you can clearly see these numbers are so close that 2 should definitely be good enough. If I, and again, 3 would work and 4 would work all the way up to, I believe it's 100 and something, and we'll take a look at that. But again, I can increase the variance, but remember, the greater I increase it by, if there are feasible successors that meet the feasibility condition and that their computed distance is now less than the computed distance of the current successor times the variance multiplier, and that is a terrible spelling of variance, then both check marks are good. We can use that path for unequal cost load balancing. All right, so let's go ahead and dig in. We know that we can use 2, and we like to use 2 to keep it as tight as we can because we don't want other feasible successors that we might not want, that aren't as attractive as this feasible successor, to be used. And we're going to do this for both IPv4 and IPv6. In fact, if I were to say show, hold on one second here, show IP EIGRP topology, I think we're going to have the similar values. Yeah, for IPv4, yeah, we've got the same values. So we are in good shape. It's that slash, wait a second, did we do, give me one second here, show run section EIGRP. Let's make sure, okay, I did do the summary address. There it is. It's 192.168.96. And where is that? One 96.0. Oh, it's all the way at the top. I literally went right by the entry and then went all the way down. So there it is. Again, same values, so we're good. So the variance is going to be 2. We just need to make sure we do it under both of the address families, and we need to do it on both sides to ensure that both links on both sides are using unequal cost load balancing. So let's get into global config router EIGRP Cisco. Do show run section EIGRP. Did I call it CCIE? I call this CCIE. All right, router EIGRP CCIE, address family IPv4 unicast AS10. Yeah, AS10. Now, where do we do the variance command? Remember, this is going to impact. We're not just doing it on a single link. We're doing it, we're multiplying for all of the current successors in the topology table. This is going to have an impact. So under topology base, this is impacting my entire topology. So variance 2, address family IPv6 unicast AS20, topology base, variance 2. And then let's go down to the distribution router here. Get into global config, router EIGRP Cisco, address family IPv4 unicast AS10, topology base, variance 2, address family IPv6 unicast AS20, topology base, variance 2. All right, there we go. All right, now this should be everything we need. So let's go back to HQ. And so let's see, and actually we could have just done it from the distribution switch. So if I were to say do show IP EIGRP topology, right? We've used the variance value, and where's the 192.168.96? I don't know why I'm struggling seeing this. There, oh boy. Oh, I'm sorry. I need to be over here on HQ. Do show IP EIGRP topology, because I'm doing the summary there. So 192.16. I'm missing. Hold on. I'm definitely missing something here, because I think I was actually looking at the wrong thing earlier as well. I think I was looking at the 172. Is it 172 on those loopbacks? Do show IP interface brief. I think I'm confusing. Yeah, I apologize. So did I do show run section EIGRP? Did I do 192.168? I did. So do you see the problem here? I summarized 172.16s and used 192.168s. So this calls for the bonus lab. So let's get into address family. Let's say address family. Actually, we'll back out here. Maybe one more. Address family IPv4 unicast AS10. I apologize. I've got my summaries are absolutely wrong. So AF interface 192.168.96. No, I'm sorry. AF interface serial Getting ahead of myself. So no summary address 192.168.96.0 255, and actually we could probably just do /21 is what I believe it was. Yeah, and we want to come back with summary address 172.16.96.0/21. Let's double check that. Yeah. So now do show run section EIGRP, and boy, do we make a mess of this. All right, so AF interface serial 01, and I'm going to say no summary address 192.168.96.0/21, and then we're going to say we're just going to recall that other command. There we go. All right, so on the distribution router, I've sorted out the summaries there. So now do show IP EIGRP topology. So let's take a look here. 172.16.96. Again, the values are the same. It's just the prefix I was summarizing didn't exist. So now we've got that sorted out. So we are the 172.16.96 here. So we're good to go. But now when I say do show IP route, do I have two paths for that 172.16.96? I do. So now I'm able to do unequal cost load balancing. And then that final question that always comes up is, well, what is the ratio? Well, we already know the ratio, but in order to figure that ratio out, if I were to say do show IP EIGRP topology, all we would have to do is we take that largest value there, that 1.7 billion, and we divide it by 1.6 whatever billion here, and that's going to give us obviously a decimal number, but we round up. So for every one packet that goes across, and we want to stay on the HQ router, let's see if we can stay on the HQ router there. So for every one packet, get this right here, every one packet that goes across the less preferable link, even though we are doing unequal cost multipathing or load balancing, two packets will go across that link, right? So it'll be a ratio of 2 to 1. All right, so we've got that sorted out. We could take a look at the IPv6, which should also be the same. Let's pull back our HQ router here. All right, which should also be the same if we say do show IPv6 route, EIGRP, and if we're looking for our summary, which is a /62 here, take a look, and now we've got two unequal cost paths across which we're able to load balance. All right, well, this is going to wrap up challenge activity number 4, EIGRP Named Mode. I apologize there for doing the 192.168s instead of the 172.16s on our summaries. But again, we got it all sorted out and everything worked out as planned. All right, enjoy your weekend, and I will see you all on Monday evening.